Z. Okay, so use Pythagorean theorem to find the missing piece. So we will choose root 13, positive. In later questions, the plus or minus will be more important. But remember, whenever you square root both sides, you're supposed to put plus or minus. But which one do you choose depends on where theta is located. So since you're saying that theta is an acute angle, or they're telling you whatever, depending on the question, that'll help you choose this. But for now, we'll assume that theta is acute, quadrant 1, meaning everything's positive. Okay, so we don't have to worry about it. So now that we filled up the triangle, we write down all 6 trig functions. Sine is, we already had that, we started with that. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Although they might not like that radical, so you have to multiply the top and bottom by the denominator. Do you remember rationalizing the denominator? That would give you 3 times 13, which is what? 39 over 13. Technically, this answer is right, but if they want you to rationalize, or if they don't accept this, then you'll have to rationalize like this. Okay, so secant will be 4 over root 3, or 4 root 3 over 3, depending if they rationalize or not. Secant theta is equal to 4 over root 13, or 4 root 13 over 13. Cotangent will be the reciprocal of that first one, maybe this one, or root 39 over 3. I'm going to box these answers because there's a lot going on here. They might accept the unrationalized answer. I don't know, but you should be able to rationalize at this point. Before we go any further, is there any steps or questions about any part of this problem? There's no rush here.
No, I'm okay.
Once you found your triangle, just use the definitions of sine. So I'm going to add the definitions just so you get stuck in our head, right? Remember, SOHCAHTOA, sine is opposite over hypotenuse, opposite over hypotenuse. Cosine will be adjacent over hypotenuse, which is 1 over 12. Tangent is opposite over adjacent, which is root 143 over 1, which is really just root 143. So these are our answers. If you practice, here we go.
since we're not having class on Monday, so is our homework due really on the 8th, the 9th?
I'll check that out in a moment. Use an identity to find the value of the expression. So these expressions will look complicated, but in reality, they're just going to be something like 1 or 0, because the way they cancel out. But on a test, you'd have to show that, right? I don't want you to just plug it into a calculator. That's not the point. You know what? Let's just get rid of the numbers. That way, you won't be tempted. Let's change this to simplify instead. Okay. The homework will have numbers, but I don't want you to just plug the whole thing in, because it'll give you the answer, but that's not the point. The point is, can you look at this and figure out, okay, what formula can I use to cancel things, right? So looking at the 9 formulas that I wrote for you last time, which one would be helpful? Let's see here. Remember how I wrote, I think one of them was sine squared theta is equal to 1 minus cosine squared. Let me double check. When it comes to
yes,
formulas.
that's correct.
All right, that's fine. Okay, so this is going to be 1 minus sine squared. So the one we need is the guy for secant, formula for secant squared theta. Because perhaps we can replace the secant. So that should be tangent squared theta plus 1. Yeah. So I'm not going to make you memorize these. I strongly advise you have all your formulas on a formula page for an exam. What I need you to see, though, is how you can replace this one with tangent squared plus 1. So I'm going to substitute here and put in parentheses so it's more apparent. Tangent squared theta plus 1. So then you notice how the tangents will cancel, right? They're the same thing. These guys are gone, leaving me with the number 1. So secant squared minus tangent squared is equal to 1, which is probably another formula. So you have questions like this where they just want you to simplify it.
I need that.
That's all good. Okay, so notice how right here, it's 86 degrees and a 4 degrees, which is complementary, would be adding up to 90, right? So there's a theorem that says these add up, then you can kind of switch it out. Let me just write it so it's more clear. So for example, the formula would be, given some angle theta, this would be equal to cosine of 90 minus whatever theta you're using, right? So let's say our sine is 4, so that would be equal to 90 minus 4. You see what I mean? And then you can just replace it. So you can use this formula to substitute like we did up here. Let me write the cosine guy here. Cosine theta would be the same. Should be sine 90 minus theta. So we can choose whichever to replace. You can replace the bottom or the top. It doesn't matter. I'm going to use, I'm going to replace the bottom, I guess. So sine 4 degrees is equal to cosine of 90 degrees minus whatever the heck they gave us, which would be 86 degrees. So that means this is really another form of 1, right? See what I mean? So these will cancel, leaving you with 1, using the complementary angle theorem, which is these two. But you could have replaced the top with sine 4, and this still would have gotten a 1. Doesn't matter. Simplify the following using the fundamental identities and or the complementary angle theorem.
Will you move it up, please?
Complementary angle theorem. Okay.
What does that say after identity? Fundamental identity.
And slash or.
Oh,
Slash right there. So some questions you may need to use both. That's what I'm saying. Eventually, we'll be using all these identities all the time. So they'll hopefully become more second nature. All right, so we have 1 minus cosine squared 38 minus cosine squared 52. So the first thing that you should hopefully notice is that 38 and 52 are complementary angles, right? So that means you can use these theorems here. So let's try that. So we know sine theta is equal to cosine of 90 minus theta. Cosine theta is equal to sine of 90 minus theta. So I'm going to change this guy into a sine. See if that helps. Okay. So cosine squared of 38 is equal to sine of 90 squared. They're both going to be squared when I convert this. Minus 38, which gives me a sine squared 52 degrees. Okay, so do the substitution. 1 minus sine squared 58 minus cosine squared. Oops, I don't know why I put 58. $52 and 52. Okay. Now it might not be obvious, but the original Pythagoras identity is right there, right? These are the same angle, sine squared and a cosine squared. If they were plus, that would be a 1. If it is not obvious, what we can do is factor a negative and change these to positive. Now we should see that these are going to be just a 1. So use your Pythagorean identity, and you'll get 1 minus 1. So this will equal 0. this? From here to here, that was step 1. Here to here, that was 2. For step 1, add some extra notes here. We use the complementary angle theorem. For step 2, I guess from here to here is more step 2. We use the Pythagorean identity. Okay. And we got 0. Is there any questions about this example?
I don't know. This might be a dumb question.
Okay. So here's a random question. Let me pick this guy. Cotangent of 32 degrees minus sine of 58 degrees over sine of 32 degrees. Okay. So we can see a complementary, right? That 38 and 52 here. 58, 32 rather. So we should probably convert one of these into something else. The fact that this one is cotangent, 32, that means I should probably change the top into some sort of 32. That way, in the next step after this, everything will be in terms of a 32 angle. So that's my reasoning here. So I'm going to change this one. So sine 58 is equal to cosine of 32. So right here, it will replace the sine. Okay. So from here to here, complementary theorem. Okay. Now, let's change cotangent. Or actually, let's change this guy. Either way. Cotangent is defined as a ratio of cosine theta over sine theta. Remember those formulas I gave you last time? Here we have cosine and sine, so this is actually cotangent. So I can change either one of them, but I'll choose the second. I change that into cotangent from here to here. The ratio property that I just wrote. After that, they cancel, leaving you with a 1. Oh, actually, that's a lie. 0, huh? Sorry, hitting record there. So go to your PDF. Can you guys see this? So sine of 60. So here's our 60-degree angle. It also has a conversion for you here. So if you were to convert this using what we did in 7.1, you would get 5/3. But you already have it there, so you don't have to do it for these angles. After a while, you'll start to remember these over time. I will not make you memorize them, even though my teacher made me memorize them. But you can use on a test. It's very helpful. So just remember the x value. These are coordinate points, right? X, comma, y. So x refers to the angle for cosine. Y is the value for sine. So sine of 60 would be the y value. So for our question, we would say the answer is square root 3 over 2. That's it, using our circle. Okay. So open that PDF so you can, that way you can look at it all the time. Just remember, x is cosine. The cosine of an angle is equal to the x value in or on your circle. Sine theta is equal to the y value on your circle. And I mean the unit circle. Okay. So let's do another example here. Okay, so when you start these questions, just make sure you find the values in your circle, and then you multiply, and then you subtract or add. Okay? There's nothing else to really do.
Okay, you said the first is the new circle. Is that correct? The new circle?
Yeah, unit circle.
Okay.
Because it's called that because it's a radius of 1. The circle itself has a unit of 1. So you're going to use these formulas to figure out the unit circle values, okay? Or you can just go ahead and change them here. Change them ahead of time. That way it won't mess with you. It doesn't matter though. Go ahead and change it, I guess. So secant is 1 over cosine. So it's 1 over cosine pi over 4 plus 13 times 1 over sine pi over 6. I'm going to put that 13 on top because it doesn't matter in the next step. So look at your circle. Pi over 4 is a 45-degree angle, right? So cosine will be root 2 over 2. So that's going to be on the bottom of the fraction. So is the sine. Because for the middle angle, they're both measured the same. Okay. So let's go ahead and use them. I'm going to put the root 2 over 2 at the bottom. 13 is going to chill up there. This will be root 2 over 2. We have to divide those fractions, which means you flip or multiply by the reciprocal, right? So this will be 2 over root 2 plus 2 over root 2 times that 13.
I have a question.
Mm-hmm.
The sine of pi over 6, is it?
Oh, that's a pi over 6, not 4.
Yeah.
Shoot. Yeah, you're right. Let's fix that right here. Thanks for telling me before we got too far. Okay, so pi over 6 on your circle should be sine 1/2, which will give us 2 over 1 times 13 over 1. So then we get 2 over root 2 plus 26. We can combine that fraction by multiplying by root 2 over root 2, which would give us 2 plus 26 root 2 over root 2, which is as far as you can go. Yeah, there's nothing else we can do. It's not very pretty, but whatever. That's how it is. We'll do a few more. All right, so we have next, 9 minus cosine squared of 30 degrees minus cosine squared of 60 degrees. So the question will be, find the exact value. And when they say exact value, that means no rounded answers, no calculator, just use your properties. Okay. Now we could just use a circle straight up at this point. You could also use a complementary to switch this out, because isn't this 60 and 30 are complementary angles, right? But technically, I could use the fact that sine squared theta is equal to cosine squared 90 minus theta. And cosine squared theta is equal to sine squared 90 minus theta. Meaning, you don't have to do it this way. You could just figure out the values right away from the unit circle. But just to practice what we learned from the last section, I'm going to do it this way, just for fun. So cosine squared 30 minus sine of 30. Which means this is the Pythagorean identity, right? If I factor that negative like last time, this would be cosine squared 30 plus sine squared 30. What is this going to turn into?
One.
Yeah, it's going to be 1, right? So this is actually going to be 9 minus 1. So all this nonsense is just the number 8.
I still have a question on this. I think I'm still confused from last time I asked it.
Yep.
When you factor out the -1, wouldn't it be -1 times 1, right? This is -1. So it would be 9 minus -1. Like, you factor out the -1, but then it just disappears. I don't know. I'm still confused.
Okay, well, let's use a different example, make it simpler. Let's say you had, I don't know, 5 minus 4 plus 3, right? We know that answer, correct? But let's pretend we didn't. If I were to factor these numbers, factoring negative from both of them, then their signs will swap, becoming a 4 minus a 3, which would become 5 minus a 1, which is a 4, right? So when I factor, it's being removed from both of these terms, swapping their signs. It's as if I divided both by a -1. Does that make sense?
Yeah.
Okay. Oops. All right, so you guys remember your functional notation? These symbols here. Like if they told you f plus g, it's from college algebra, that was equal to f of x plus g of x, right? Do you remember this?
Yeah.
And they had them one for minus, times, etc. I'm not gonna write all of them, but I need you to know that if you see this, you're separating two different functions, right? The one that I do want to write more about is the composition. Do you remember fog and Goff? Right, that meant that f was composed with g, meaning g is inside the f function, a combination function. And vice versa, this would mean that f is inside the g function, composed with g. G composed with f. Does that seem familiar?
Yes.
All right,
Yes.
so the next few questions are going to assume you know how to do that, or all about it. So let's do a few just in case you don't. We are going to say find the value of f plus g of 60 degrees. So they defined f, defined g. So all you have to do is separate these functions, right? Just remember, what the heck does this mean? Well, all that means is add the functions together. That's a 60, not an x. So that will be the same as saying f of 60 plus g of 60 degrees. And f is sine, so you would say that's just saying sine of 60 plus cosine of 60. And then just look at your circle. Sine of 60 will be root 3 over 2 plus 1/2. And as simple as this gets, it's going to be root 3 plus 1 over 2. So don't let this question confuse you. All it really was asking was add these guys together. That's it. It's just the notation was coming from the class before this, right? Making it seem more difficult than it should be.
I have a question. Why?
Right. So the questions should define the trig functions or the f and g first, and then they'll ask you something. For example, let's say let f of x equal cosecant of x and h of x equal 2x. Then they'll ask you find f composed with h at a particular angle pi over 6. And all that means is, I'll write it over here. So this means f of h at pi over 6. Okay? So don't the notation mess with you. We just gotta figure out what the heck is h of pi over 6. And once you find that, you plug it inside the f, because that's what this is saying. F of h at that number. Okay? So here's h. Let's just go ahead and do that. We'll do that over here on the side. So h of pi over 6 would be the same as saying 2 times pi over 6, which would give us pi over 3. Right? So this value is going to go in here because that's what this is equal to. So we can just use f of pi over 3 instead. but f is just cosecant. So cosecant at pi over 3 is what we really want. Take a roundabout way to ask this question. What is cosecant of pi thirds? But what is cosecant, right? Cosecant of pi thirds is equal to 1 over sine of pi thirds. Right?
In the
Oh.
book, it gives us the scale. So like for pi over 3, it shows you that like it equals to pi over 6 as well. Do you want us to memorize that or just focus on the mathematical part?
Chart?
Like
What kind of chart? Like it tells you what sine is at pi thirds, stuff like that?
yeah.
Yeah, it's the same as the circle.
Okay.
So no, it's fine. I want you to get used to the circle though, because you're gonna be
Okay.
using that a lot more than the little charts they give you in the homework.
Okay.
I hear you. Okay. What is sine pi thirds? You're saying like they actually have this guy, right? So you don't have to figure it out, but you should get used to it. I understand your question now. So what is sine of pi thirds? Let's check.
Square root of 3 over 2.
Yeah, looks like, yeah. Square root of 3 over 2, which will flip over to be 2 over root 3, which we then rationalize to 2 root 3 over 3. Okay. Now the picture is pretty difficult. And sometimes you need to read this like, over 3 or 4 times. So finally you start to see what the heck are they saying? What is this picture? So they say it's a right angle triangle. It's my attempt of a right triangle. Has a hypotenuse of 4 inches. So this guy is 4. Right? If one angle is 44 degrees, so I know that one of them has to be 44. I'm going to choose this guy. Since it's a right triangle, this one has to be 90. Even though it doesn't look like it because I can't draw. But well, who cares? Find the length of each leg. So they want to know these sides. But we can't use Pythagorean theorem because we're missing 2 sides, right? So we have to use the trig functions to help us out. So we use the angle and the hypotenuse to help us, okay? So we do know that if I choose sine of 44 degrees, that this is technically equal to the opposite side over the hypotenuse, right? So that means that sine is equal to some side, I don't know what it is, over 4. So you can solve for opposite, right? See what I mean? So isolate opposite, or you can call it x, doesn't matter. Multiply both sides by 4 to cancel that fraction. So these will cancel. So now I know that 4 sine 44 is equal to the opposite side. I don't know what that is, so we have to use our calculator. Any scientific calculator will be fine. You don't need anything fancy. 9 degrees. So it's about 2.77. The question should tell you how far to round. Let's round to the nearest tenth. So opposite is equal to 2.8 inches. Adjacent, I don't know yet. We'll figure it out soon. Hypotenuse is 4 inches. Okay. Okay. All right, so opposite side, I'm just gonna go ahead and write it right there. So let's use sine, or cosine rather, to find the other piece. So we know that cosine of some angle that we choose, so if I choose 44, then that means adjacent over hypotenuse would be equal to it. Right, which would be adjacent, which is unknown, over 4. So same deal, multiplying both sides by 4. That will be 2.9 based on the calculator. So adjacent is 2.9 inches. Is there any questions about any of
Can you
these
show
steps?
us how you do it on the calculator? I saw how you did it, but I'm trying to figure it out now.
Oh yeah, that's fine. So you just put the 4 and then type in the cosine function and type in your angle. You just need to make sure that your calculator is in degree mode because we're using degrees. If you get something different than from what I got, it's probably in radian.
I got 3.9 for my cosine. It was like 3.9 and something.
I did too.
Yeah, so go to mode and change radian to degree. Assuming you have some sort of TI something. TI 30, 83, 89 should be similar. So the next one, similar to a homework problem, they have a pretty picture of a canyon. I'm not going to draw that for you. Find the distance from A to C across a gorge. Illustrated in the figure. Okay. So basically picture like, I don't know, there's some land over here, land over there. And we want to know what's this distance from there to there, get across, right? There, I'm sure it's right close to the edge, but who cares? But we're on this side, so we can measure from here to here, being 90 feet. We have this hypotenuse with an angle of 40 degrees. So if they ask you, how far is that distance? Well, just use your triangles, right? You just need to decide which trig function should I use. So we are missing the opposite side. So I think, and we're missing hypotenuse. So sine and cosine are not going to be helpful. You're going to want to use tangent because you have adjacent and you want to find opposite. Remember, tangent of any angle is equal to opposite of that angle over adjacent to the angle, which means tangent of 40 degrees is equal to 90 feet, or some unknown distance. We'll call it.
Isn't adjacent 90?
Oh, yes, thank you. Yes. This will be
Opposite over 90.
There we go. So then, similar like we did before, just multiply that fraction out, and we should be good. So multiply by 90 on both sides. Yeah, that's right. 90 times opposite over 90 cancels, which means that this value is now the opposite side. Okay. Plug that into your machine. 90, 10, 40. Let's round it to about 1/10. Fine. The distance across will be 75.5. Excuse me.